Good day, viewers. My name is Darlington Okoka, and I welcome you to DELWIT Electrical YouTube channel. Today, we are going to be discussing on the Ohms law experiment. I was amazed when I visited my alma mater, and I went to our laboratory, the engineering lab, for the 200 level students, and I discovered that we're still making use of the analog ammeters and voltmeters, and to my greatest surprise, they were carrying out the Ohms law, which took me aback to those days when I used to go to the lab, to the school's lab, to carry out such experiments. So the students were, especially those who are not electrically inclined but are trying to cope, they were taken aback because they don't tend to see what they were doing. The lab was filled up with students, and a technologist was there trying to explain to them. But I said to myself that yes, it's good to use all these analog or digital equipment, but softwares are already in place to ensure that these students actually understand what they are doing and they get to see it physically. What you see, the way the current flows physically will make you not to forget what you've been taught in the classroom. So I said I was going to do a video for them and make the video popular on my YouTube channel so that other students can also go. I'm also going to create a video on how to train students on how to use all these circuit analysis softwares, LiveWire, Pro Tools, Circuit Maker, Multisim, and the rest of them. I'll do a video subsequently. So Ohms law, yeah, it's good to know, it's good to understand what Ohms law is. It's good to carry the definition in your brain and know, but it's also good to know the application, because 80% of most of the circuit analysis you are going to be doing is going to be revolving around Ohms law and Kirchhoff's law. So let's start with Ohms law. Ohms law states that the current flowing through a conductor, and when a current flows through a conductor, the voltage between the beginning point and the ending point is directly proportional, in as much as the resistance between them is constant. And we're going to show you two circuits. We're going to show you a voltage divider rule circuit that carries out Ohms law, and we're going to show you a direct circuit that carries out Ohms law. With this, if you carry out this experiment yourself, you would understand that everything is quite easy. So we'll go straight to it. Mathematically, now you could see that V is directly proportional to I. V is directly proportional to I. So we're saying that if R is constant, therefore V is equal to IR. Then our I will now be equal to V over R. I believe that is very okay. So now we'll now go straight to the circuit. Let us make the circuit. Now on our circuit, we are going to take a voltage source. Let's take this voltage source to be 9 volts. 9 volts. This is live wire. Now we're going to take a source, a passive component, a resistor. Let's take a resistor to be 2 kilo ohms. We're going to change this one now to 2 kilo ohms. Now, in that case, we're going to connect. Ammeters are usually connected in what? In series to what you are measuring. So let's go to measuring equipment, and you take your ammeter. So this is your ammeter. Now let's loop them together. We loop them together, and we'll loop them together. Now your voltmeter is connected in parallel to your load. So we parallel this and we parallel this. So this is a perfect example of your Ohms law. Now let's look at it. This is in series. So for us to know the current, this is our ammeter. Our ammeter is going to measure our current. So since it's going to measure our current, let's see what it's going to give us. Our vote is in parallel to this. So definitely the voltage here is the same as the voltage here. So the voltage here is supposed to be this 9 volts. So we see whether our voltmeter is going to give us 9 volts. Then on this particular place now, we said from our previous equation, we said V is equals to IR. Then our R is equals to V over R. So 9 divided by 2 will give us 0.045. So let's run this equation and see if it's going to give us 0.045. So you can see current is flowing is flowing. At this our ammeter, we have 4.5 milliamperes, which is 0.045. Then our voltmeter, we're having 9 volts because the voltage here is what is capturing. So you could see that this our circuit is a perfect example of Ohm's law. We could also do another circuit to check our voltage divider rule to see if the voltage divider rule too exhibits Ohm's law. So we're going to take our power source. If we take our power source, also let's take 10 volts battery. Take this to 10 volts. Take our 10 volt battery. Then we have our passive equipment, the resistor. Let's take this resistor. Take this other resistor too. And let's call this resistor 3 kilo ohms. And let's call this resistor 2 kilo ohms. We loop them together. We loop them together. And we loop them together. Now we want to measure the voltage across these 2 ohms resistor. So let's take a voltmeter and put it across this, and let's measure the voltage. Let's measure the voltage here and the voltage across this 2 ohms resistor. So you could see that this is like a voltage divider rule. The voltage divider rule says that the voltage across this resistor is equal to, if we are measuring this voltage, R2 divided by R1 plus R2 times 10. So if we want to measure this now, it will be 2 divided by 2 plus 3 times 10. So obviously the voltage across this now, let's do the mathematical calculation and see if we are going to arrive at the same thing. So mathematically, we are saying that our V2 is equal to V2 is equal to 2 divided by 2 plus 3 let's put it then times 10. So if we do this now, our V2 will now be equal to 2 divided by 5 times 10 will now be equal to 4 volts. So let's see, we're getting 4 volts here. So let's see if we're going to get 4 volts here when we simulate this circuit. So let's simulate this circuit and see. You can see now that our voltmeter is giving us 4 volts. So this is just, you can see the current is flowing, and it's giving us 4 volts here. So you could use this software. Obviously, you can definitely use this software to do whatever you intend to do and get your direct result. So this is a simple explanation of what is Ohm's law and how we achieved that. So with this, I think we are good to go, and we have been able to explain how Ohm's law can be experimented in the laboratory. Alright, with this little experiment we've just carried out, using our series circuit and using the voltage divider rule and simulating the circuit and giving us our output both on an ammeter and voltmeter, you could see that we've been able to prove that Ohm's law is actually in existence and Ohm's law is actually true. So we're going to be taking various other circuits and we're going to be simulating with our live wire, and we're going to be getting an output to show that most of our principles that are being taught in the classroom are gotten directly. So I believe I've been able to educate you on the basic principles of Ohm's law, and I think with this simulation, this Ohm's law will definitely sink to your memory, and even if in your sleeping bed, you could recall what V and how the relationship between V and I is. Thank you very much, and hope to see you in subsequent videos.